Hello everyone, my name is Sunil. In this video I am going to talk with you guys about a very famous book of physics. From today I am starting a series of videos in which I will be discussing on books of physics written by Stephen Hawking, and in today's video I am going to discuss about a book that is A Brief History of Time. So here is the book. It's one of the most popular books on cosmology written by Stephen Hawking. In this book he has actually tried to explain the origin and the evolution of the universe, and he has written this book for the readers who have no prior knowledge of universe and who are actually interested to learn something new. In this book he writes about some cosmological phenomena like Big Bang, black holes, and some basic concepts like space and time. In this book he mainly discusses on two important theories, quantum mechanics and general relativity. In the end he talks about the arrow of time and a theory that unifies all laws of physics to describe everything in this universe in a very comprehensive way. The most interesting point of this book is that this book does not contain any type of mathematical equations except E equals mc square, and you all know this equation. This is very famous, world's famous equation. This book was first published in 1988 and very soon it became a bestseller and I think sold more than 25 million copies. Okay, now let's talk about the contents of the book. The first chapter is our picture of the universe, what we think about the universe and how did all these ideas came into existence, and the theories that we study today, how these have been discovered. In this chapter he starts with the history of astronomical studies and the ideas of Aristotle and Ptolemy. Aristotle concluded from all his observations that Earth was round. He observed the increase of the altitude of the North Star from different positions on Earth. In his model, the Earth was stationary and Sun and other planets and the stars went around the Earth. Further, Ptolemy made a planetary model describing Aristotle's thinking in more detail. But this idea, Earth being the center of the universe, was objected by Copernicus in 1514. After a century later, Galileo and Kepler supported the model of Copernicus. Kepler also presented a model in which planets moving around the Sun in elliptical orbits instead of circular orbits. Later in 1687, Sir Isaac Newton presented a mathematical form to understand the model of Copernicus. In early days, there was also a debate on the topic of the beginning of the universe. Some were saying that universe existed forever and few believed in the creation of universe at a specific time. In 1929, astronomer Edwin Hubble discovered that all galaxies are moving away from each other. Consequently, there was a time between 10 and 20 billion years ago when they all were together in one singular, extremely dense place. This discovery brought the concept of the beginning of the universe at some finite time in past, which we now call as Big Bang. Then the second chapter is space and time. In this chapter he discusses about the Newtonian theory of rest and motion. There is not any concept of absolute rest or motion, everything is relative. Aristotle and Newton also believed that the time is absolute. They believed that two synchronized clocks always measure same time for an event, irrespective of their state of motion. The rate of advancement of time is same everywhere, means in all parts of the universe. There was not any concept of time dilation and speed of the propagation of light. The actual propagation of light was given by James Clerk Maxwell, who saw that the light travels with a fixed speed through any hypothetical medium that is at that time called ether. Then this idea of hypothetical medium called ether was disproved by a very famous experiment known as Michelson-Morley experiment. Then finally in 1905 Einstein's special theory of relativity came into the picture. In fourth chapter he discusses on different models that showed that the universe is expanding. In chapter 5 and 6 quantum mechanics has been discussed, like Heisenberg uncertainty principle. The more accurately you measure the position of a particle, the less accurately you could measure its momentum. In chapter 6 and 7 he has discussed on black holes and some concepts related to black holes like space-time singularity, event horizon and Chandrasekhar limit. He also talks about how black holes emit radiations known as Hawking radiation. In chapter 8 the concept of the beginning of the universe is discussed, how the universe started and how it might end at some point of time. In chapter 9, he talks about why we humans observe and experience time to have a certain direction, from past towards the future. In chapter 10, he has discussed on the search of a complete unified and a consistent theory which can take into account all the partial theories which we use to understand different kinds of events in the universe. In the end, he summarizes everything we humans have always wanted to make sense of the universe and tried to find out the reason behind our own existence. In early days, events were considered random and controlled by emotional spirits of humans. People do not have the idea of all the events follow certain laws of nature. But as the human civilization progressed, they started observing the events around them and found some patterns in them. Laplace suggested in the beginning of the 19th century that everything in this universe could be predicted by using some laws governing them. And finally, in 20th century, quantum mechanics set limits to our prediction. Okay, I told you many things about this book, and if you want to know more about these things in a very simple and precise way, you must buy this book. I strongly recommend everyone to buy this masterpiece. If you are an expert in these theories, then also you should read this book at least once. This book just brings out the curiosity in you to know and seek for the beauty of the nature. That's all in this video. I hope you found this video informational and helpful. In the next video, I will come up with another book of Stephen Hawking.